Before we delve into EDA, I just want to do a quick detour and explain what's special about pandas and why pandas has been so useful for data science. And there is actually another library that we're not touching in detail in this course, but I would encourage you to investigate this further in DataCamp, for example. And this is NumPy. NumPy was developed before Pandas, and Pandas is built on NumPy arrays. And I'll just explain you quickly what that does and what it means. And the core word that you need to learn is vectorization. This is a really critical concept that I think is useful to understand. So Python is famous for being slow, and a lot of people slag Python off for being a slow language. And one problem in Python is that it blocks parallelized operations. So whether you have one core on your CPU or whether you have 10 cores on your CPU, you can only run one thing at a time. You cannot do parallelized actions. And this is a good example here where we have a list. And in Python, lists are memory inefficient objects anyway, so each number is stored separately and handled separately. And if you want to, for example, if you have a very long list with 10 million entries, if you want to process each item in one go, like for example, you want to do a multiplication by 2 or division by 2, you have to build this into a for loop, and that takes a while. So you have to go one by one, call this in memory, transform it, store it back. So this is a very slow operation. Whereas NumPy arrays are similar to lists, but they can only have one data type. So only, for example, floats in this case here. And NumPy is built on C under the hood, which is a much more sort of low-level language. And in here, the whole array is stored as a single object in memory, and that can be processed in one go. So if you do this operation times 2, all the values are processed in parallel in one go, and this is speeds it up of between 10 and sometimes even 100 times faster. I'll give you a quick demo of this to make this a little bit more understandable and see this in practice. So here we are importing NumPy into our notebook, and now here we are generating a list with 10 million entries. So this uses the random library we touched on in the last lesson. So this command here, it's a list comprehension. I'll talk a little bit more about list comprehension in a minute, but this generates a list of 10 million values. So let's do this now. Takes a little bit of time. 10 million values is quite a lot. And it's generated it. So now let's run this operation where we divide every value in the list by 2. And here we have a magic command. These are special commands that you can use in notebooks like this. There's several of those, but this timeit one is very useful if you want to just check how long does your operation work. So you have these 2 percentage markers here that to say do this for the whole cell, and then timeit is a command this will understand. So if you run this, we can now it takes actually longer because it does it several times to get the average of how long this takes. But then it gives us, okay, this took about 800 milliseconds with some variation per loop on my Mac. So this is pretty slow for an operation. There is another way of doing this, which runs slightly more efficient. So if we do this again, here this is using a list comprehension, and it's worth learning this. I will actually generate a notebook, a revision notebook that will explain you how to write list comprehension instead of for loops in Python. It's a better way of doing this. Let's see if this is actually faster. And yeah, slightly faster, but not terribly much better. So here what it does, it takes each value in the list one by one and changes it. Whereas if we do this with NumPy, we can generate a NumPy array. So this is basically also a list of these integers, but in our now this is in a much more memory efficient object, and we can now run the same operation just in a vectorized way, dividing this per 2, and you see this takes only 33 milliseconds. So almost 20 times faster. So that's 20 times. If you have a, if things takes minutes or, tens of minutes, sometimes with very large data sets, you can reduce this considerably. And this makes now this marriage of Python, which is really easy and nice to program, and then under the hood C operations that speed things up, have been extremely popular. And NumPy really has been sort of the core driver why Python is so popular in data science. And one very famous way of applying this is in AI, where we have packages like PyTorch or TensorFlow that are also built on NumPy that do this type of processes billions of times, and where the speed really matters. Also, NumPy arrays are much more memory efficient. So if you run this code here, just checks the memory usage of this object. So you see the list is 369 megabytes versus the NumPy array only 80 megabytes. So it's a lot more memory efficient as well. So now you understand in principle what vectorization means. So processing all the values in a list at once. And this is also happening in a pandas array. When you have only numbers in the array, you can also use vectorized operations, which speed things up tremendously.